Assalamu alaikum students, welcome to science class. Today we will continue chapter 11 of your science book, that is force and pressure. Students, in previous class we learned that force could be a push or a pull, and a force arises due to the interaction between two objects. Now in today's video we will try to learn more about forces. Clear? Students, we all know that an adult man can apply large force on an object, whereas a child can apply a small force on an object or on the same object. Clear? This means that a force can be larger or smaller than the other force. The strength of force is expressed by its magnitude. The magnitude of a force is expressed in the SI unit of force called Newton. So the SI unit of force is called Newton. Okay, and the abbreviation of Newton is N, means we just used to write capital N in place of Newton. Clear? Okay, what is Newton? 1 Newton is the force which can make an object of 1 kg mass to move at a speed of 1 meter per second. Along with the magnitude of force, the direction in which a force acts is also to be specified. This is because if the magnitude or direction of the force applied changes, the effect produced by the force also changes. When two forces act on an object, then two cases arise. Either the forces act on the same direction or the forces act in the opposite direction. Clear? Now let's take first case. If the two forces applied to an object act in the same direction, then the resultant force acting on the object is equal to the sum of the two forces. It means when two forces act in the same direction, their effective magnitude increases. Let's understand this with the help of an example. Suppose there is a heavy box which one man can move only by pushing it very hard. If two men push this heavy box in the same direction, it becomes much easier to move the heavy box. This is because when the two men apply their forces of push together in the same direction, the two forces add up to provide a much bigger force. And this bigger force can move the heavy box very easily. Okay. Now let's take second case. If the two forces applied to an object act in the opposite directions, then the net force acting on the object is equal to the difference between the two forces. In other words, when the two forces act in opposite directions, their effective magnitude decreases. Now let's understand this with the help of an example. Suppose there is a heavy box lying on the ground. Let the two men or two boys push this box from the opposite direction. Assuming that one of the men is stronger of the two and applies a larger pushing force than the other man, we can say that the box will move in that direction in which a larger force is applied by the stronger man. The box will, however, move very slowly in this case. Do you know why? Because the net force acting on the box in this case is equal to the difference in the magnitudes of both the two forces applied by two men, and this net force is small. Okay students, if the two forces applied to an object are equal in magnitude and act in the opposite direction, then the net force acting on the object is zero. Since the net force acting on the object is zero or nil, we can say, so in this case the object does not move at all. It remains in the same position. For example, if the two men push a heavy box, the same box which we had taken in previous examples. So if there are two men and they are pushing a heavy box from opposite direction by applying exactly equal forces, then the heavy box will not move at all. It will remain where it was. Now let's take a familiar example of this case of equal forces acting in opposite direction is provided by a game like you might have played, that is called tug of war. In this game, two teams of persons pull at a rope in opposite directions. Members of both the teams try to pull rope in their direction. When the two teams pull the rope equally hard by applying equal forces, the rope does not move in any direction. At this point of time, when the two teams are applying equal but opposite forces to the rope, due to which net force acting on the rope is equal to 0, and hence the rope does not move at all. Actually, the equal and opposite forces applied on the rope cancel each other's effect. Ultimately, the team which pulls the rope harder by applying greater force wins the game. Understood?